In this video, we're going to take a look at section 4.2, which is multiplication of polynomials. Now, before we get into multiplication of polynomials, I want to do a quick review on multiplying variables with each other. Now, we have a product rule for exponents, and what it states is if you have a raised to the nth power times a raised to the nth power, this is equal to a raised to the m plus n. So when you are multiplying variables with each other, what you're going to do is add the exponents with each other. So for example, if you have x squared times x to the third, our rule tells us to add the exponents. You have x raised to the 2 plus 3, which gives us x to the fifth. But now let's take a look at why this rule works. So if we rewrite x squared, this is really saying x times x. We have times, and now x to the third power, this is x times x times x. But now if we rewrite it in exponential form, x times x times x times x times x, this is really just the same as x to the fifth power. But now instead of expanding it out, so sometimes you might end up with some large exponents, instead of expanding it out, we could use our rule right over here, and we could just add the exponents with each other. Another quick example, if we have, say, y raised to the 7th times y raised to the, say, 17th, I'm not going to go ahead and expand these out. Okay, first that would take too much time. I can just go ahead and use my property. This would become y raised to the 7 plus 17, which gives us y raised to the 24th power. Now let's go ahead and take a look at our first objective for this section. We're going to take a look at multiplication of any two polynomials. So what you're going to do is multiply the coefficients first, then multiply the variables. So remember, the coefficients, these are the numerical values of the term. So you'd multiply those with each other, and then just multiply the variables. And when you multiply the variables, use the property that we just learned. Add the exponents with each other. So our first example, we have 9y squared times negative 2y. Now when you're working this out, you could rearrange these terms. So we have the property where we could rearrange the terms, so we could put the numerical values next to each other. So this would be 9 times negative 2 times y squared times y. And now if we multiply it out, the 9 times negative 2 gives me negative 18. And then y to the second times y, this gives me y to the third power. So I added the exponents for my variables. So I added the 2, and there's really like a 1 right here for my y. Now, once you get the hang of this, you don't have to necessarily rearrange the coefficients so they're next to each other and the variables next to each other, then multiply. You could go ahead and just multiply it right away. Let's take a look at another example. So we're going to multiply. We have negative 5x y to the 7th z to the 4th times 18x to the 3rd y to the 2nd z to the 8th. Okay, so first let's go ahead and multiply the coefficients with each other. Negative 5 times 18, this will give us negative 90. And now multiply the x's. X times x to the 3rd gives us x to the 4th. And then y to the 7th times y to the 2nd gives me y to the 9th. And then z to the 4th times z to the 8th gives me z to the 12th. And now we just multiply these two monomials with each other. Let's take a look at this next one. This is a little bit different. So previously, the other two examples that we saw, we were multiplying two monomials with each other. In this particular problem, we're multiplying a monomial with a binomial. Okay. So this is 2xy times this whole binomial, times 4y squared minus 5. So what you want to do in this case is you're going to go ahead and distribute, and then just multiply it out the same way you did in the previous example. So 2xy times 4y squared, this gives us 8x y to the third. And now 2xy times negative 5, this gives me negative 10x y. So notice when I multiply the 2xy with the negative 5, all I had to do is just multiply the 2 and the negative 5 with each other, because this 5 didn't have any variables attached to it. Let's take a look at another one. Now with this example, also a little bit different, because now we're multiplying two binomials with each other. So you might have heard of a rule that you could use to multiply two binomials, which is FOIL. Okay, I'm not a big fan of FOIL because now you have to memorize what those words, what those letters mean. Then you have to, so this would be like first, but then you have to figure out, okay, what are my first terms? Then you have outer, then you have to determine, okay, what are my outer terms? Then you have inner, okay, you have to decide what are your inner terms, and then you have last. Okay. What I prefer using is, let me erase this. You're going to go ahead and take your first term in the first binomial. You're going to take this 5x squared. You're going to distribute it out to both of those. Okay. So you have 5x squared times x. This gives us 5x cubed. 5x squared times 3 gives us 15x squared. Once you're done distributing out that first term, take the second term in the first binomial and distribute it out to these as well. Negative 4 times x, you get negative 4x. Now negative 4 times 3, you get negative 12. And what we just did right there is FOIL. But we didn't have to sit there and memorize what FOIL meant, and we didn't have to worry about the order that we multiplied it. Once you're finished multiplying, always check to see if you could combine like terms. If you take a look at what we ended up with after we distributed, all of these have different variable parts, so none of these are like terms. We can't combine any of these with each other, so this would be our final answer. Let's try this one out. So we have 2y plus 3 times 3y minus 4. So let's go ahead and take our first term, it's 2y. We're going to distribute out to each one of these. So 2y times 3y, I get 6y squared. 2y times negative 4, I get negative 8y. Now take your second term in the first binomial and distribute out to each one of these as well. Now 3 times 3y, I get positive 9y. 3 times negative 4, I get negative 12. But now always take a look to see if you could combine like terms. So I have negative 8y and a positive 9y. These are indeed like terms. I can combine them with each other. So I get 6y squared, negative 8y plus 9y, I get plus y, and minus 12. And then this would be our final answer. Next example, this one's a little bit different because now we have a binomial times a trinomial. See, now FOIL only works if you're multiplying two binomials with each other. But the method that I just showed you works for anything. Take the first term in your binomial, and then you're going to distribute it out to all three of these terms in the trinomial. So first p times p cubed. This gives me p to the fourth. Now p times 4p squared gives me 4p cubed. P times negative 5 gives me negative 5p. Okay, so we're done distributing out that first term. Now take your second term and distribute out to each one of these as well. Distribute out to all three of those terms again. Now negative 3 times p cubed, I get negative 3p cubed. Negative 3 times 4p squared, I get negative 12p squared. Negative 3 times negative 5, I get a positive 15. Now check to see if you have any like terms. Now when you're writing out your final answer, write it out in descending order, meaning start with the highest exponent and then work your way down to the lowest exponent. So we have p to the fourth. Now I have a 4p cubed and a negative 3p cubed. I can combine those with each other. I get positive p cubed. Now I have a p squared term here, but I don't have any like terms with it, so I can't combine it with anything. So you just write it out the same way. So I have negative 12p squared. Then I have a negative 5p here. I don't have any other terms that have just p, so there isn't any like terms for that one. So I'm just going to write out as minus 5p. And then I have this constant over here. Okay, I have a plus 15. Now we don't have any more like terms. We can't simplify any further than this. Okay. Our next objective, we're going to take a look at squares of binomials. So what happens when you have a binomial raised to the second power? So we have two formulas here that we can use. So if you have a plus b raised to the second power, this becomes a squared plus 2ab plus b squared. And now if you have a minus b raised to the second power, okay, almost the same formula. There's just one key difference there. It's that minus sign. So your result would be a squared minus 2ab plus b squared. Now, the way to obtain these formulas, let me show you the first one. So a plus b raised to the second power, this is really saying a plus b times a plus b. And now if we go ahead and multiply these two binomials just like what we did with the previous problems, take your first term, distribute it out. So a times a, I get a squared. A times b, I get ab. Now take your second term, distribute it out to each one of those terms as well. B times a, I can rewrite that as ab, a times b. And now b times b, I get b squared. But notice here we have some like terms. I have this ab and ab. I can combine these with each other. This becomes a squared plus 2ab plus b squared. And that's how we obtain this formula right over here. Now, a common mistake I see a lot that students make a lot of students would just go ahead and distribute out this 2 to both of these, and then you would write out a squared plus b squared. Okay. But just be careful here, you cannot do this. Because what are we missing there? We're missing that middle term. Okay. So you can't distribute out that exponent to both of those terms. So just be careful. Okay. Now let's work this next example out using two methods. We'll use the formula, and then I'll show you another method that you could use to multiply them out. So x plus 8 raised to the second power. So if I'm using the formula, so I'm going to use this first formula I have where it's a term plus a term and then raised to the second power. Okay, so my a in this problem is really this x. Okay, so I'm going to take x and I raise it to the second power. Okay. Now to get this middle term, this is 2 times a times b. So I have 2 times x and then times 8. So 2 times x is 2x, and then times 8 gives me 16x. Then I have plus. Then you take your b term, which is our 8, and you raise that to the second power, which gives us 64. Now, once you get the hang of using the formula, you can start multiplying these out pretty quickly. Another way that you can work it out is you could rewrite it twice. So x plus 8 raised to the second power, this is x plus 8 times x plus 8. And then you go ahead and just do the same thing that we've been doing. Take your first term, distribute out to each one of these. So x times x, I get x squared. X times 8, I get 8x. Now take your 8 and distribute out to each one of these as well. So 8 times x, I get 8x. 8 times 8, I get 64. But now notice we have some like terms. I can combine the 8x and 8x with each other. I get x squared plus 16x plus 64. And we end up with the same solution. Let's take a look at this next one. So we have 8xy minus 4z squared. What I'm going to do for this problem is I'm going to go ahead and write it out 2 times. I see often this is the method that students prefer. Okay, so I wrote it out twice, and now you can start distributing. So 8xy times 8xy. So I have to multiply the 8's with each other, the x's with each other, and the y's with each other. So this gives me 64x squared y squared. Take that term again and distribute it out to negative 4z. So I have the 8 times negative 4 gives me negative 32. And I have x, y, z. Sorry, let me just create some more space here. Okay, so we have 64 x squared y squared, and then we had minus 32 x, y, z. Now take the negative 4z and distribute out to each one of these as well. So negative 4z times 8xy, this gives me another negative 32x xyz. Now negative 4z times negative 4z, this gives me positive 16z squared. But we're not quite finished yet. We have to combine like terms. I can combine these two middle terms with each other because they have exactly the same variable part. So I get 64 x squared y squared. I have minus, combining those gives me negative 64 xyz. I have plus 16z squared. And then this would be our final solution. So we have one last objective here. This is the product of a sum and a difference. So this is also has to do with multiplying binomials. So they're almost the same binomial, but the sign in the middle is different. One of them is a plus and the other one is a minus. So we do have a formula for this. This is equal to, so if you have a plus b times a minus b, this is equal to a squared minus b squared. So let's take a look at how we would obtain that formula to see why it's a squared minus b squared. So take your a, distribute it out to each one of these terms. So a times a is a squared. A times negative b gives me negative ab. Now distribute this b out. So b times a, this gives me a positive ab. And now b times negative b gives me a negative b squared. And now when you combine like terms, negative ab and positive ab cancel out. So I'm left with a squared minus b squared. And that's how we get this formula right over here. Okay. So let's take a look at this first example. So with the first example, let's go ahead and use the formula for it. And then the next example after that, I'll show you the other way that you can do it. So you have 4y plus 7 times 4y minus 7. So you're going to take your first term. So notice our terms are the same here. We have a 4y and a 4y, and we have a 7 and a 7. But the only difference is that the first one is plus, and then the second one is minus. So you're going to take your first term, which is 4y. You're going to raise that to the second power. You're going to put a minus. Then you take your second term, which is 7, and you're going to raise that to the second power. So you have 4y raised to the second power. So just remember this is 4y times 4y, which gives us 16y squared. We have minus, now 7 raised to the second power gives me 49. And now we just use the formula to find the product of these two binomials. let's take a look at one more problem. So we have 5w minus 13 times 5w plus 13. So notice again how it's almost the same binomial, but it's just the sign that's different. So let's go ahead, let's distribute out this 5w. So instead of using the formula, let's go ahead and use the method that we've seen so far in this section, the method that's like our go-to method. 5w times 5w, this gives me 25w squared. 5w times 13, this gives me 65w. Take the negative 13 and distribute out to each one of these. Negative 13 times 5w, again, negative 65w. Negative 13 times positive 13 gives me negative 169. Just remember, you have to combine like terms. So I could combine the 65w and negative 65w. These two terms cancel out with each other, and I'm just left with 25w squared minus 169. And if you were to use the formula, you would get exactly the same answer. So that was it for 4.2. As always, if you have any questions, just email me and I'll get back to you.